So here we have a set, and we're asked to place these numbers in the following sets: the natural number, the whole number, the integer, the rational number, the irrational number, and the real number. So for natural number, another way of saying natural number is the counting number. Okay, so if I go to a classroom and I ask my students to count off, they wouldn't use -4 to begin with, or they wouldn't use 3.5 to begin with. Naturally, they would begin with 1, 2, 3. That's the counting number. And that's what we refer to here as the natural number here as well. So here, if we're counting, this one can be a little bit tricky. Square root of 81, I'll simplify and call that 9. So from this list, I can identify 1 as a counting number. That is natural. And I identify 9 as a counting number as well. So that concludes our natural number set. Just keep in mind, this is a counting number. For the whole number, we introduce one number with the natural number set. That's the 0. So for the whole number set, here I identify 0. And it includes 1, 2, 3, just like the counting number. So we'll hit 1, we'll reach 9, and that is it right there. And I made another mistake. I'm sorry about that as well. You mentioned square root 81. I should write this. My math lab is picky. So this has to be, this has to be something else. I ate too much turkey over the break. Sorry about that. Yeah, because the students are using my math lab and it's picky. Okay.
Okay. Take number 3. Whenever you're ready.
So here we have a set, and we're asked to place these numbers in the following sets: the natural number, the whole number, the integer, the rational number, the irrational number, and the real number. So we're going to begin with the natural number. The natural number is also referred to as the counting number. So if I walk into a classroom and if I ask my students to count off, naturally they wouldn't begin with -4. And they also want to count off using 2.5. Naturally they would begin with 1, 2, 3, and counting so on and so forth. So the natural number set is going to begin with 1. Now, notice the square root of 81 right here. The square root of 81 can be simplified to 9. So we use this 9 just as a note to say, yes, this is a counting number. Therefore, the square root of 81 belongs in this set. For the whole number, we introduce an additional number with the natural number, and that's 0. So I identify a 0 in my whole number set. So we have 0, 1, 2, 3. That's the whole number set. And out of this, I identify 1. And again, just keep in mind, the square root of 81 is 9. 9 is a whole number. Square root of 81 goes here. Now, the natural number takes care of the positives, the 1, 2, 3, 4. And the whole number introduces the 0. So right now what we're missing is the negative number. So the integers will introduce the negative numbers -3, -2, -1. 0, 1, 2, 3, and so on and so forth. So I notice a -3 here. That's part of my integer set. Notice we have 0, 1, and 9. 9 is an integer, so we're going to include square root of 81 in the integer set. Now, for the rational number. The rational number has two definitions. The first, if a number can be represented as a fraction, then it's considered rational. So, if you have fractions to begin with, okay, that is a rational number. So we're going to include -2/3. Okay, if a number can be represented as a fraction, then it is a rational number. Now, consider the following. I'm looking at square root of 81. which can be simplified to 9. And we ask ourselves, can 9 be represented as a fraction? 9 can be represented as a fraction if we place it over 1. Therefore, 9 is rational, so we're going to place square root of 81 right here. And if we continue down this set, I see negative 3. And we ask ourselves, can negative 3 be represented as a fraction? This number can also be placed over 1. So negative 3 also belongs in this set. 0 can be placed over 1. 1 can be placed over 1. So these two numbers can also be represented as fractions. So they are included in the irrational number set. So that's the first definition. A number is rational if it can be represented as a fraction. Now, the second definition involves decimals. So for the decimal, we're looking for a few things. We're looking for a decimal that repeats, has an obvious pattern, or completely stops. Okay? This is also known as a rational number. So if I go to 0.25, what I want you to notice about 0.25, it's 0.25 and it doesn't go any further. It stops. So if a decimal has this behavior, it's considered rational. 2.7, and notice, it doesn't continue on and on. It's 2.7 and it stops. And if we have this behavior, again, it's rational. Now think about the square root of 7. Okay, square root of 7 is equal to 2.6457 513, and it continues on and on and on. And notice, with this decimal right here, it doesn't repeat the same number. For example, if this was 2.646464, then it repeats, and it has the pattern 64. But here, this is very random, and it doesn't stop. Right here, it doesn't stop. So this is not considered a rational number. So our rational numbers, we stop here. So for the irrational number, the irrational number has the opposite effect of the irrational. So whenever you're considering decimals, we're looking for the following: random, non-ending decimals. We're looking for random, non-ending decimals. So notice, 645, 753, and this number continues on and on and on. It's very random. Okay, there's no obvious pattern to this decimal right here. So we call the square root of 7 irrational. Irrational. Finally, the real number. The definition of a real number is a number that can be plotted and found on a number line. So keep in mind, square root of 81 simplifies to 9. 9 can be found on a number line, so it's a real number. Negative 3 can also be found on a number line. Negative 2/3. We can also find 0. 0.25, that's a number between 0 and 1, so we can definitely find that on a number line. 1. And then I want you to think about this square root of 7 once again. True, we called it irrational because it's random and non-ending. But the question is, can we still find this number on a number line? 2.6457, so on and so forth, is a number between 2 and 3. It's a number between 2 and 3, so we can identify this square root on a number line. Therefore, it's a real number. 2.7 falls short of 3. That can also be found on a number line. And that is the definition of the real number. So for this set, we were able to find each and every set that each number belongs to all the way through the real number.